Hello friends, today's question. A string with one end fixed on a rigid wall passing over a fixed frictionless pulley at a distance of 2 meters from the wall has a point mass m 2 kg attached to it at a distance 1 meter from the wall. A mass small m 0.5 kg attached at the free end is held at rest so that the string is horizontal between the wall and the pulley and vertical beyond the pulley. What will be the speed with which the mass capital M will hit the wall when the mass small m is released, taking G as 9.8. So this is the figure. We have a capital mass M, small mass m. Initially this mass is held at rest so that the string is horizontal and here the string is vertical. As soon as this mass small m will be released, this capital mass M will traverse a semicircular path, a quarter of the path in the form of arc, and it's going to strike this vertical wall. And we have to find out the velocity with which this capital mass M is going to strike the wall. So let us draw this figure. So initially we have mass m along the pulley, and this is small mass m, and let us call this position as A, this as B, this P, and this as Q. So as soon as this mass small m is released, and this is capital M, as m is greater than this small m, this is 2 kg and this is 0.5 kg, so this is going to move upward. So accordingly the mass at A is going to form a arc and is going to strike the wall. So let us draw that figure. So initial position of the small m is B, and this is the final position. Let us call as B prime. So we travel this distance B prime in upward direction. So this is final position of M, and this capital M is going to traverse a path like this from the arc and is going to strike the wall. Then we can say this will be this is point P, this is our A, and this is the final position A prime, and this is Q. This is the basic motion of the small m as well as capital M. So we can say from here that PQ is in the horizontal position by the supporting mass M at position B. Secondly, as capital M is greater than small m, so because of this, as mass m is released, it moves from B to B prime, and mass capital M will traverse a circular arc of radius PA prime, which will be equal to nothing but PA, and which will equal to 1 meter. As the total distance, this distance is given as 1 meter, and the total length is given as 2 meter. So we can say this will be 1 meter, as well as this will be also 1 meter. Therefore, we can say PA prime will be equal to PA, and which is equal to 1 meter, and hits the wall. So we can assume, suppose mass capital M hits the wall by velocity capital V. So from here we can also say that thus the velocity of mass small m with which it rises will be also equal to capital V. Next, we can use the conservation of energy and write the equation. You can say from conservation of energy, we have you can say as the height, first of all we can say decrease in the potential energy of capital M. Here we can say decrease in the potential energy of mass capital M is equal to increase in its kinetic energy, increase in kinetic energy of mass capital M plus increase in the kinetic energy of small m plus decrease in the potential energy of small m, decrease in the potential energy of mass small m. So this capital M, there is a reduction in the height, and therefore there is a decrease in its potential energy, which will be equal to increase in the kinetic energy of the capital M, decrease in the potential energy of small m, as well as increase in the kinetic energy of small m. Now if you substitute the relevant points, so we can say capital Mg multiplied by PA prime is equal to half m v square plus half m small m rather v square plus mg multiplied by b prime, and we can find out our b prime. So we can say our b prime will be equal to pa prime plus a prime q minus pq, and if we substitute the value, or rather we can say this formula further, we can say pa prime plus our, you can say this will be pa square plus pq square square root minus pq. So we can say from here b prime is equal to 1 plus square 2 square and its square root minus 2, and which finally comes at square root of 5 minus 1. So we got the b prime. Now we are going to substitute value. Capital M is given as 2 kg, so this will be 2 multiplied by 9.8. pa prime is 1. We have half into 2 into v square plus half into 0.5 into v square plus mass is 0.5, 9.8, and we have square root of 5 minus 1. So this can be written as 1.25 v square is equal to 9.8 minus 0.5 into 9.8, and this will be square root of 5 minus 1. So we can write this will be equal to 19.6 minus 6.06, which will come equal to as 13.54. So we can say our v square is equal to 13.54 divided by 1.25, and you can say the velocity v will be equal to 3.29 meter per second. So this is the velocity with which mass capital M hits the wall. So this completes the question. Here there were only two important things. That first of all, drawing this figure, as B moves from B prime, this mass capital M is going to move from A to A prime in a arc form whose radius will be given as 1. So this will be our 1 meter. And second is formulation of this equation based on the conservation of energy. So we can say decrease in the potential energy of mass M as it moves from A to A prime will be equal to increase in its kinetic energy plus increase in the kinetic energy of this mass small m moving from B to B prime, and decrease in its potential energy. So these are the only two important steps in the solution of this question. This completes the question. Thank you.